Hi everyone, this video lesson is for our second day in lesson 15. It is for your remote learning day on Wednesday, February 24th. So the expectation is for you to watch this video along and follow along with the Pear Deck link that is in the classwork tab in Google Classroom that is due today. So we are going to just be continuing to talk about how to solve problems that involve exponents now. So we've done a lot of work with writing exponents. What does the base mean? What does the exponent mean? And so now we're going to kind of put it together and talk about some word problems. So this is our first word problem. It says Julie's brother says that instead of paying her $40 that he owes her, he's going to give her $2 today and then double the amount she has each day for 6 days. And our job is to figure out, should Julie accept her brother's offer? Why or why not? So this kind of problem is involving repeated multiplication because something is going on for 6 days, and each day that goes on, the amount that Julie's brother is going to pay her is doubling. So when things are doubling or tripling or quadrupling, that's a clue that double the amount. That's a clue that we're going to be using exponents to solve this problem, or repeated multiplication, which is the shortcut for exponents. Or sorry, repeated multiplication has a shortcut using exponents. So I want you to try to figure this out on your own. So pause and do some thinking before continuing, and then we can compare what you did to some of the book's answers. This is on page 146. So if you turn there, you're going to see the answer. Don't go ahead of that. I want you to do some of your own thinking first. So pause this and try to figure out if Julie should accept her brother's offer. If at the end of 6 days, is she going to actually get more money than the $40 that he originally owes her? All right, so hopefully you tried to do some thinking on your own. If you turn in your books, if you happen to have them, if you're in school, no one's in school. It's Wednesday. What am I thinking? Oh, Mrs. Trumble. So if you look at this page on your Pear Deck, it is explaining a couple of different ways you could have thought this through. So one way is to actually list out the days and figure out the amount per day that actually would be given. So on day one, he's going to give her $2. And then since she has $2, she's going to get it doubled on day 2. So you see that being multiplied by 2. And then on day 3, she has $4. So you see that 4 being transferred over and then doubling. And then you take that answer from day 3, bring it over to day 4, double that, yay. And then you do the same thing for day 5, bring over the amount that she has for day 4, double that, and you have an ending amount of $64 at the end of day 6. So because we're doubling or having it 2 times the amount of money that she had the previous day, we can show what's going on with repeated multiplication. So you see the exponential notation written out with repeated multiplication here in this second model. So we still have the days, and then we have the starting spot. We just don't have the totals on this table. We just have, here's 1, 2, then 2 of them, 3 of them, 4 of them, 5 of them, and 6 of them. So this is actually the connection to the exponents that we've been talking about. So maybe you were doing it day by day as a way to think about it, or hopefully you're seeing that connection now between what you can do each day and then what's going on with the repeated multiplication. All right, so just a couple of wrap-up questions with Julie's problem, which is in this next slide. So really, you didn't have to write anything on here, but just understand that you can show this problem using multiplication of those 2's over and over again. So now we want to do some thinking. So how can we write an expression? Remember, an expression involves numbers and operations for the amount of money that Julie has on day 6 using exponents. So here's the application. And if you wanted to refer back, it's basically asking you, what is this as an expression using exponents? This is an expression using numbers and multiplication. It's all strung out. There are 6 of them, and the number that is repeated is our base. So that is our 2. Just a little review. That is the base, B for base, and then it is being repeated 6 times. That is the exponent. Okay, so 2 to the 6th power is how we say that. And then just going to get rid of this for a second because it looks like a 6. Then how much money is actually asking us to calculate. What is the value of 2 to the 6th power? And should she take her brother's offer? The multiplication actually was already done for us. And if you wanted to verify with 2 to the 6th power, you can use your calculator. Remember that exponent key we learned about is right, there it is, next to the 7. So you can pop that in to your calculator. 2 to the 6th power is 64. So 2 to the 6th power, and then we have 64. So is $64 a better deal than 40? Let me think. Yes, I'd rather get $64 than 40. And so, yes, she should take her brother's offer. So Matt is thinking if Julie starts with $2, she will have $12 after 6 days. Explain what he's doing wrong. So he is thinking that 2 to the 6th power equals 12. And this is a common mistake that people and kids, not just Matt, make. And they think that, hey, this little 6 needs to just be multiplied by the 2 to get 12. That's what he did. And realizing that that exponent doesn't mean that you just multiply the 2 numbers together. It actually means that there are 6 2's, just like we saw over here. All right, so let's try a couple more together. So Maria is buying a new carpet for her bedroom. Her bedroom is in the shape of a square. Actually, note that, circle it, underline it, put a square around it, something. And the length of each side of the square is 12 feet. Make a note of that dimension when you're digesting this problem. We're asked to write and then simplify an exponential expression, wordy, to find out how much carpet she needs. So we're dealing with carpet in a room, and the bedroom is in the shape of a square. I'm actually going to draw that. I'd like you to draw that as well. If this is a square and we're dealing with carpet, that's an area problem. Okay, so area of a square is going to be side times side. Remember that from yesterday? So another way to say that is that the area is going to be side squared. Okay, so you can write like I'm doing or typing. And so we need the dimension. There's 12 feet on one side, and then there's 12 feet on the other. Make sure you are including your units whenever you're dealing with area. So we have 12 feet on this side of the square, and then we have 12 feet on the other side. So if we're asked to write and simplify, that means we have to write using exponents because it's asking specifically for an exponential expression. And then simplify just means what is the exact number once we do the math, okay? So writing it, we're going to use our area equals side squared. So that's 12 squared, okay? Actually, I should say it's 12 feet squared. So it's 12 feet times 12 feet. That's what that means, including the units along the way. And when I multiply 12 times 12, I could use my calculator, but I know this one is 144. And we have to make sure, just like our exit ticket yesterday, that we include our units of feet with the exponent too. Okay. So just to clarify, I should have included feet here. Sorry, I'm going to use a parenthesis. So to put that unit in is worth going back and actually typing that in, or in my case, writing that in. So we're taking that 12 feet and we're squaring it, which means 12 feet times 12 feet, which equals our answer of 144 feet squared. Okay. So the next one we're doing together is to write and simplify. So we're doing the same thing, but now it's just an expression that's given to us. We didn't have to come up with it like we did with the area problem. So this is our exponential expression. It has an exponent and it's an expression. Therefore, we call it exponential expression. And so we want to write and simplify. What does this mean? To write means to stretch it out, meaning don't do the math right away. By the way, it's not 20. It's not 5 times 4. It's 4 of our bases, which is 5. So when it says write, we need to actually stretch it out first. And we see all the 5s. And then we can do the math. Okay. So if you did not want to do this in your calculator, you can do this by multiplying 5 times 5 and 5 times 5, which are both 25s. And then we have to multiply 25 times 25. So you see how I did this little arrow thing down? It's almost like the opposite of our exponent key. And then we have to multiply 25 times 25. We did this actually on day 1, if you are remembering. 5 to the 4th power is the number 625. All right, so for the next few minutes, I want you to actually pause the video, and in your Pear Deck, the next 3 slides, yes, so that does say practice and problem solving up here. And we are going to try on our own number 5, 6, and 7. They're all related, just so you know. I had to put number 7 on this next slide. This is a challenge problem, so if you're stuck, don't worry about it. We're going to go over it. And then you can try number 8 and 9. So I want you to try this on your own first, pause, and then resume to check your answers with mine. Okay, so like any good problem solver, you need to read and underline and mark up your problem. So 5 students received the same text message at 9 a.m. Each of them sent the message to 5 more students at 10, and each of those students sent the message to 5 more students at 11. So you're seeing that pattern of things are increasing times 5 with each hour. So that is repeated multiplication, and we are going to represent the situation with exponential expressions and then simplify. So we should have recognized that the first time was just that 5 people got the text message. Okay, so this is like a phone tree on text messaging. Then at 10 o'clock, those 5 people sent it to 5 more. So that's 5 times 5, which is 5 squared. And so we have 5 squared equaling 25 for our second row. And then at 11 o'clock, the same thing happened. So now we have to increase it to the 3rd power. And then that would be 5 times 5 times 5, which is 125. We did a lot of work with the base of 5 on day 1, so hopefully that wasn't too difficult. So if the pattern continues, how many students would receive the text message at noon? So we actually have to extend this to 12 noon. And I'm just going to make another chart over to the right so that I can then continue my pattern. So basically it's asking you what is the pattern. We're increasing our exponent by 1. So that's the explanation of how to use the pattern. So I'm just going to switch over to my text here. Increase the exponent each hour that passes. Would be one way that you could explain, not the only way. Okay. So now that we've explained what we did to find 5 to the 4th, let's actually figure out what 5 times 5, and I'm using my little asterisk instead of my dots. That is a workaround to drawing it. We have 5 of them, and then we should get the answer. Oops, 4 of them. My bad. 625, like we had before. So number 7 actually asks us to continue the pattern and then find the time that we will get the answer of 15,625 and explain how you know. So I know this was optional, but if you were up for the challenge, great. We're going to continue this. This is 625, okay? And then we're going to just continue the pattern. So at 1 o'clock, it would be 5 to the 5th. And that is what I was typing down here by mistake. 5 times 5 times 5 times 5 times 5. And when we pop that into our calculator, 5 to the 5th power is 3,125. So we're not there yet. Yes, I am doing this at home. And that is my dog. So that's at 1 o'clock. Risa. It's just the garbage truck. All right. So at 2 o'clock, we're going to do this once more and see if we're at 6,000. Or no, what was it? 15,000. So 5 to the 6th power is what we needed. That 15,600. I am so sorry. I know. Risa. Quiet. So at what time? That would be 2 o'clock. So 2 o'clock. And then an explanation could be we're multiplying. We multiplied 5 times, continuing the pattern. One way that you could have explained it. All right. The last 2 questions was to write and simplify an expression with an exponent. So this was exactly like the try it. Okay. And we want to represent the volume of a cube with each edge 6 inches long. So this is something that we did yesterday. And when we do volume, it's to the 3rd power. Remember that cubed volume unit. So when we're writing and simplifying, we want to use the side times side times side. So we're going to do 6 times 6 times 6. Okay, there we go. As our expanded. Okay, so let me back up and show you the 6 inches is being cubed. And I have to actually write that exponent in with my pen because that's just easier. So there's my 3, and that's going to equal That 6 inches, adding in my unit there, times 6 inches times 6 inches. When we do 6 to the third power, we are going to get 216, and then we have to have our inches and make sure that our inches are also cubed. Hopefully got 216. And again, this is a repeat question with different numbers. Chin is the same, making the same mistake as Matt. 2 to the fifth power is 10. Nope, he did not use the exponent the right way. So correct the value, 2 to the fifth power. It's going to write in that exponent because that's easier. 2 to the fifth power equals, let's get my typing in there, 2 is the base, and it is appearing 5 times. That is very different than 10. 2 times 2 is 4. So if you wanted to think about it that way, 2 times 2 is 4. And then I still have another 2 here. I know that this is 8. And I have to make sure I'm going back and multiplying that by 4. So I'm getting 32, not 10. So what did he do? He thought the exponent was just a number to multiply. So I'm just going to add 5 in here. Again, don't make that mistake. The exponent tells you how many times the base is repeated. The base is a factor, and we are going to continue to work with exponents tomorrow. Yay, I get to be in school with you or in a meet, so I'm excited about that, and we will continue to work with exponents. I hope you have a great rest of your day. Remember to do the exit ticket question that is in your classwork before you submit it. And if you followed along and written your work into Pear Deck, I will see it and you will get credit for today's work. Thanks, everybody. Bye.